Okay, we are recording. And what we're particularly looking at here is PC3 insofar that it's a partial sequence. So here we have a messenger RNA. And with PC1, it was very clear. We had a 5' UTR, that's this area right here. We have an open reading frame with a start and a stop, and we have a 3' UTR. Very straightforward. Okay. PC2 was called non-coding. Even though it was clean, it was non-coding because I think there was a break, but the break was like really near the stop codon, so you had none of this. All you had was a little bit of the 3' UTR. And UTR codes for nothing. It's called 3' UTR, untranslated region. So PC2 is non-encoding, but PC3 is an interesting one. PC3 looks like it's a break, but the break is in the middle of the ORF, somewhere there. So yes, you don't have 5' UTR. This is PC3 for WSSP. All you do have is you have an ORF and you have the 3' UTR, but you don't have 5' UTR. And therefore, you don't have the start codon. Okay, now how do I know this? How do I know? BLAST X. It's all about the BLAST X. BLAST X tells you. So I take the sequence from my period 12 donor sequence here, and hers is correct. That's the sequence. That's PC copy. That's PC3's sequence after we cropped it out of the plasmid, and I put it in BLAST X. I already did it 2 hours ago. BLAST X, pasted it in, press blast. Pretty easy. And the first thing I look at is graphic summary. There's a couple clues here to tell us that it's a partial sequence, that I think it broke. Do I know if it truly broke? I don't know, but it looks like it did. Here's why I think that. Number one, there's a little break right there. Say a little break. Okay. Number two, this is the cDNA. That turquoise seafoam color bar, that's your cDNA. It's also your messenger RNA, same thing, right? That's your clone, your cDNA. Well, if I had the start codon, this red wall would be in the middle. But instead, this red wall is shifted all the way left, and immediately you can see my proteins are matching my DNA from base 1. Immediately they're matching. That tells you that this is a partial. That your ORF is broken and your DNA is immediately coding for protein. There's no 5' UTR and a start codon. That's gone. So this is the 3' UTR. That region, this region right here. Here's the stop codon, somewhere just after 500. That's the stop codon. Stop codon. Where's my start codon? I don't know. It's gone, right? It's well gone. I don't have it. But colored bars are great, right? But let's look at the numbers. Here's more evidence. If you click alignments up here, alignments, it shows us that immediately I start coding. My DNA starts coding into lysine, KPF. K is lysine, KPF GCN. Immediately I start coding into KPF GCN lysine. See, and that is in the middle of my subject, KPF NC, close enough, 200 amino acids in. So immediately I'm coding. It's not like I'm coding 50 into mine. I'm coding immediately. Now I know you say, wait a minute, Jones, this is query 3, right? Query 3. That's not immediate. It technically is because I'm in frame 3. So frame 3 means that I'm skipping the first 2 bases and I start coding with my codon at the 3rd base. That's why it says query 3. If I was in frame 1, it would say query 1. If I was in frame 2, it'd say query 2. Query 1 and, DNA bases 1 and 2 are still important, but they're just not shown there because I'm in reading frame 3. So this is, once again, a partial sequence. To summarize, this is a partial sequence. My DNA is immediately coding for protein. To summarize again, it's a partial sequence. Shoom, the ORF was cut. I don't have that. I only have this. Okay. So Rutgers then in DSAP asks you to annotate the sequence, asks you, they want to know, what's the 5' UTR, if there is one? There isn't. What's the ORF, if there is one? There is. It codes immediately. And what's the 3' UTR? They want to know this under the review section in DSAP. That's this section in DSAP. Let me go up here a little bit. They want to know that in this section right here. What's the 5' UTR? What's the ORF? What's the 3' UTR? So how do we do that? Well, there used to be a program called Toolbox and that program called Toolbox is gonzo. It's no longer there. It's because Flash is not supported in 2021, so it's gone. We have to deal with that. So there's a new non-Flash-based program called ORF Finder, and ORF Finder is fine. Here's how it works. It's just a little trickier to use in Toolbox. Toolbox is very, very plug and play, very easy to simple to see. This is fine. It's just a little trickier, so just bear with me. Here's how we use ORF Finder. You get your DNA. Okay, copy your DNA from your BLAST N or your question form to crop ends. It doesn't matter. Get your whole DNA sequence from DSAP. You go to the ORF Finder and you paste it in. Okay, but here's the difference. You have to tell ORF Finder what you're looking for. Now, I already know this is a partial because I looked at BLASTX. BLASTX tells me this is a partial because my DNA is immediately coding for protein. That's unequivocal. I mean, those are red lines. That's unequivocal. Look at my E values, -104. That's unequivocal. That's awesome evidence, right? That's 1 over 10 to the 104th power. That this is random. It's not random. It's definitely a partial, right? It's definitely a partial. So what we do is we put that into ORF Finder and we click. We don't click ATG only. We click any sense codon. So if you think it's a partial, click any sense codon. I'll just write that over here. If it's a partial, if you think it's a partial, which PC3 is, I'm telling you, click any sense codon. For PC1, you wouldn't click that. For your own clone, which you'll do in the late winter, you don't know what to click. You'll have to try both. But after you blast exit, you'll have a good idea. And I can help if necessary. That's the beauty of your own clone. It's discovery. So once you click that, it's pretty easy. You click submit, and it shows you your proteins. Now, it gives you 6 different reading frames. You don't care about the negatives. You only want the positive reading frames because those are your template strands. You only care about the positive. And the cool thing is it gives you the best one up top. In this case, it's called ORF6. That's irrelevant. What's relevant to us is the fact that it's a positive strand. That means it's the normal cDNA direction of 5 to 3. You don't want the negative strands. Forget those. The negative strand is the other side of the DNA. So you want the positive strand. Frame 3, we saw that in BLASTX. It starts at base less than 3, meaning it's reading frame 3, but it's really base 1. That's why it says less than 3. It's base 1. And it stops at 509. That's our stop codon, the end of it. So my ORF then is 1 to 509, guys. It's 1. I'll write it down here. Your ORF is 1 to 509. That's your ORF, open reading frame for PC3. And if you click right here, graphic summary probably easier to see. That's 1. And look, that's about 509, isn't it? Looks like 509 to me. See, it's about 509, and that's 1, clearly. That's your open reading frame. And so therefore, your 3' UTR must be 510 to the end, right? It has to be 510 to the end. Your ORF is 1 to 509. Your 3' UTR is 510 to the end. And your protein is right here. Look at that. That's the good part about this. It tells you your protein. Your protein is that KPFGCN S to SQ. Oh, let's just do KPFGCN. See that? KPFGCN, KPFGCN, KPFGCN. Look at BLASTX. KPFGCN, KPFGCN. See that? So this is proof to us that we found our correct protein. KPFGCN, KPFGCN. QLASQYL. QLASQYL. That's our protein. So when you do BLASP, guys, when you do BLASP, you're going to use this. That's your protein. That's your protein. So I like this personally better than Toolbox. It's a little hard at first, but it shows you a lot, and it gives you clear numbers. Okay, your ORF is 1 to 509, and your 3' UTR is all the bases after that. Now, one more thing. How do you get the rest of those numbers? Well, you could use Finch if you want. This is kind of optional. You can go to Finch. There's our whole cDNA sequence. But the original numbers are in there. But you can take those out quite easily. I'm highlighting all the code before the inserts start, before that T56. Ready? Delete. Here we go. Bye-bye. All gone. So now I start at that T1. And remember that, do you recall that our ORF is T1 to 509? Well, now I know my base is T1. Let's go look at 509, what that was. Let's go see. And it's right there. Look at that. So it's A509 all the way back to T1. T1 to A509. That's my ORF. And my 3' UTR is all the code after that. Here's my 3' UTR. G510. That's where we stopped initially, to A651, 2, 3, 4, A654. All right, I'm gonna pause the video. I hope that helped everybody. If not, ask a question in class. It's never a problem. Bye-bye.